Okay, 7.37. We have two continuous random variables with a joint PDF equal to this guy. So when x and y are both between 0 and 1, and x plus y must be less than 1. So that is the support of x and y. So it's essentially just this is x, this is the y, this is the 1. So that's the support of the PDF, right? So the joint PDF can take positive values over this triangle only. Now we want to find the joint PDF of the random variable z, which is equal to x plus y, and w, which is just equal to x. Okay. So now remember that because x and y are between 0 and 1, so the w has to be between 0 and 1. And also the sum of x and y less than 1, so that means this guy has to be less than 1, but it's also greater than 0 since both x and y are positive. So that means z and w, they are both numbers between 0 and 1. So if we are trying to find the joint PDF of z and w, the joint PDF can only be positive when z and w are both between 0 and 1. Okay, so now according to these two, we're going to define our function u to be x plus y and x. So given x and y, it's going to output this two-dimensional vector. And this is just essentially the matrix form is this. So the inverse of this function u is, we call it v. V is just the inverse of this guy times whatever the zw is. Okay, so that's just this guy. The inverse of that is pretty easy to compute, which is this. So the v of zw is just going to return a two-dimensional vector with w and z minus w as the two components. And the Jacobian of this inverse is just this matrix actually, right? So it's just this matrix, and determinant of this matrix is just -1. Now we're ready to use the formula. So the PDF, the joint PDF of z and w, which is this guy, is just a joint PDF of x and y at this v of zw. And then this is the determinant of the Jacobian. So first of all, this guy. So the f of this guy, f is 24xy. But x is equal to w, y is equal to z minus w. So 24w, z minus w. And this guy here we said is, we calculate is just -1, so absolute value is just 1. So combining all of them together, so it's just this. So that is the joint PDF of x of z and w, where z and w must be between 0 and 1. So it's actually the square right here. Okay. Outside of this square, the joint PDF will be 0.